Today we are going to learn how to build drives. Drives are chronic implants for extracellular electrophysiology. Drives include tetrodes sent down into the brain that pick up neural activity. This video is intended to introduce you to drives, as well as provide a visual reference for how certain steps are carried out. Please be aware that many of these steps take hours of practice to master, so don't be discouraged if they seem difficult. It will likely be overwhelming at first, and that is absolutely okay. Okay, let's get started. Here is a list of things we'll be needing to start. We'll need a drive body, grease, a Q-tip, and we want to break it in half. As you can see, the drive contains channels. We want to use the broken end of the Q-tip to apply grease to each of the channels. Here you can see I'm spreading grease around the interior of the drive, and now I'm tracing the channels to get it deep within. Now we can clean up the excess. However you'd like to accomplish this is okay, but our end result should be grease deep within each channel, but not all over the interior of the drive. The drive contains lots of moving parts, and grease is essential in keeping everything running smoothly. Now is also a great time to mention that there is a 1-to-1 ratio between channels and tetrodes, such that if we are building a 64 tetrode drive, we would have 64 channels. There are also hybrid drives which contain 32 channels and thus 32 tetrodes. In this video, I will be showing how to make a 64 tetrode drive, but the steps to make both are essentially the same. You may also have noticed that I greased only a small portion of the channels. For time's sake, I will show the technique of each step, but not carry it out fully. For the next step, we want to begin with the greased up drive body, shuttles, which are these green pieces, wire cutters, and forceps. The shuttles come in pallets, and we'll be using the wire cutters to separate them. This shuttle flew away from me, and it's a good reminder that that will probably happen to you too from time to time. Watch how I now reposition my finger to prevent this from happening again. We now want to trim off the bits of plastic on the sides of the shuttle. This is important to prevent shuttles from catching on one another as they move within the drive. Because of the flying parts, safety glasses are recommended, though they are not required for this step. Shuttle fit within the drive is crucial for smooth movement, so shuttles come in different sizes, such as thin, regular, and thick. Please note that shuttles for the hybrid drive are different than the ones for the 64 tetrode drive, so please make sure you're using the correct ones. We now place the shuttle in each of the greased up channels. Once again, shuttle fit is very important. They should be snug such that they hinge up and down when pressed, as shown, but do not move easily. Now it's time to secure the shuttles. We will need the drive body, a turn tool, and screws. The top of each channel has a hole through which we send the screw. The back of each shuttle also has a hole. Getting the screw through the shuttle can be tricky, and I suggest viewing the drive from the side as shown to make sure the screw is going through the shuttle. It may also be helpful to gently press the shuttle against the back of the channel to hold it in place. The screw should eventually fill this hole at the bottom of the channel. This ensures that it has been properly secured. There are a few failure points worth mentioning. If the shuttle rides all the way to the top of the channel, unscrew the screw and start again. Overextending the shuttle can break its threads and render it unusable. Finally, if the hook of the shuttle breaks at this step, the shuttle should be replaced. Now we want to cement the screws. Let's once again grab our drive body, vivid flow, turn tool, curing light, safety glasses to protect ourselves from the blue light. And finally, this is also a step for which we'll want to use gloves. Using the vivid flow, we want to flood the well around the screw head from the top and then from the side. We then connect it to the other wells with a thin line of vivid flow for structural integrity. Use the turn tool to twist the screw a half turn each way, allowing the vivid flow to fully seep into all the crevices. Now it's time to cure the cement. Grab your glasses and shine the UV light on each screw for 5 seconds. Next, we want to glue magnets to the drive body. This allows it to sit in the drive holder, which is necessary for the steps to come. We'll need glue, a weigh boat in which to mix it, a wire to apply it, and 2 magnets. Another pair of magnets is already glued to the drive holder. Because magnets have 2 poles, we want to make sure that the drive and the drive holder attract one another. Placing our magnets on the ones in the drive holder allows one to mark the necessary configuration. We then apply glue to the magnet hole in the drive body and insert the magnet. Make sure that the marked side is facing inwards. There are 2 magnets on opposite ends of the holder for increased stability, so this step will be carried out twice. Next, we'll be making the cannula bundles. We'll need cannula tubes, a plastic board to cut on, a drive base, and please remember that this varies on the project, so make sure you're getting the right one, a razor blade, heat shrink, epoxy, a wooden Q-tip, pointed Q-tips, glue, and a weigh boat. First, we want to line up the tubes, measure the halfway point, and cut them in half. We then send each half bundle through a piece of heat shrink. We want to make sure that the tubes don't bend and that we don't lose any in this step. The other end of the bundle is then inserted into a hole in the drive body base. Remember that there are 2 bundles, so this step is done twice. One of the tubes fell out, so I had to put it back in. As you attempt these steps, please keep in mind that they can be tricky, so don't be too hard on yourself. We now want to dab a bit of glue at the junction of the cannula bundle and the heat shrink to keep the heat shrink in place. Upon using the heat gun, the heat shrink will now form a nice, tight collar. We now want to mix some epoxy. It's important to get equal parts of the clear and yellow liquid. The yellow is much more viscous, so it's best to press only on the yellow side while dispensing. Then, stir vigorously. We want to spread the epoxy all over the cannula bundles, applying some pressure to ensure the epoxy seeps between the tubes. We now remove any excess epoxy. Removing excess around the heat shrink is particularly important. After waiting for 12 hours, the cannula bundles are ready to be cut. We begin by using the razor to slice right below the heat shrink. Using forceps creates a nice, flat surface to guide the razor. However, we want to be sure not to squeeze the tubes too tightly. Only use carbon tip forceps for this. We now want to make a cleaner cut. Measure 4 millimeters out from the base of the drive and cut again. If the surface is not flat, you may have to shave it down with another cut. It's time to cut shuttle tubes. We'll once again need our plastic board, shuttle tubing, and a diamond knife. Shuttle tubes should be cut to 36 millimeters. On the plastic board, we want to score the shuttle tubes with soft strokes of the knife. Always score in the same place so as not to damage the rest of the tube. The tube should then break at the point at which it was scored. I have also included an example of what not to do. You can hear the tubing crunch below the knife. Now we insert a shuttle tube into each of the holes in the cannula bundle. Because the surface of the cannula bundle is actually quite small and requires a microscope to view, I'm using a picture for clarity. The shuttle tubes will poke out the other end of the cannula tubes and we will hook them onto the shuttles. When we are done with this step, there should be minimal crisscrossing between the shuttle tubes. This will require some rearranging of which tube goes to which hook. We can then glue the shuttle tubes in place. We will once again need glue, a weigh boat, and a wire. With the wire, we can transfer a drop of glue to the junction between the shuttle tube and the shuttle. Be careful so as not to get the glue anywhere else. In about 15 minutes, we can cut off the excess shuttle tube above the shuttle. Now it's time to pour epoxy, which we already know how to make, into the drive. This is one of the most risky steps, so caution and a steady hand are vital. As I slowly remove the weighboat, I'm careful to make sure no drips fall on the shuttle tubes or shuttles. Here is a detailed picture showing what we wish to achieve with the epoxy. This arrow points to the junction between the shuttle tube and the cannula tube. Any epoxy here prevents movement. The epoxy level must be here, such that all shuttles can still move, but the cannula tubes are supported with hardened epoxy. Before pouring epoxy, it's important to be aware of the lowest shuttle tube to cannula tube junction so that the epoxy level is below it. After waiting 24 hours, we can clean up the surface of the cannula. All we'll need is tape. Tap the sticky side of the tape gently against the cannula to remove dust.